All right. Geometry, we're beginning chapter 6. Chapter 6 is a very quick unit. We're going to get through it before winter break. So please keep up with your work. Next Thursday, we will be taking our tests for Unit 6, which means next Thursday will be the last day I take any late work. I will give you a one-day extension to Friday, and that's it. So please make sure you are keeping up with this work. 6-1, perpendicular bisectors. So we have two theorems. Perpendicular bisect. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So basically, it's saying that this perpendicular bisector is the midpoint of side AB. And so therefore, AD and DB are equal to each other. They are the same. So for example, CD is perpendicular. We know it's perpendicular, not because it tells us, but it also makes a 90-degree angle. Only perpendicular lines make 90-degree angles. And is the perpendicular bisector of side AB. Then AC and BC also must equal each other, because if you remember our right triangles, we see they share a side. We have an angle, and these sides, so this side, of course, equals itself. This side and this side equal each other because this side bisects it. Then with right triangles, if two of your legs equal, then the hypotenuse is also equal. Now the converse of the perpendicular bisector. If a point is equidistant from the endpoints, if these points is equidistant from that, then it is on the perpendicular bisect. So if we are told that these are equal each other, that makes this the perpendicular bisector. In the triangle, A equals, I guess I did not pull that example to actually show the picture of that. I do apologize. Let's use them. Okay, so let's use the perpendicular bisect theorem. It wants us to find EF. No, what are we finding? Yeah, we're finding EF. Okay. So, and it tells us that FG is perpendicular bisector of GH, 90-degree angles, and based on my perpendicular bisect, this equals itself. And then this is the perpendicular bisector, it forms a 90-degree angle. This side and this side both equal. And if this side equals itself, these two, right angle, two legs equal, your hypotenuses equal each other, so we can set them equal. So EF is 4A minus 15 equals, okay, A plus 12. Now we can solve for A. Let's see, our biggest loser is singular A, so subtract A from both sides. You end up with 3A minus 15 equals 12. Now we have a basic two-step equation. Let's add 15 to both sides. 3A equals 27. If 3A equals 27, divide both sides by 3, and A equals 9. Have we solved for EF? No, we have not. We're going to substitute. 4 times 9 minus 15. All right. 4 times 9 is 36 minus 15. 36 minus 15 is 21. Have we solved for EF? Yes, we have. 21 equals side EF. Okay. Basic straightforward math. We had an easy time with this in class. Example 2. Use the converse of the perpendicular bisector theorem. So it wants us to find xy. Okay. So wi equals wy. Okay, wx and wz are congruent. So if this equals itself, those are congruent. These are both right angles. That means this side has to equal that side. And so x, y must equal 22.4. No math required. All right. Let's go over to the side that does require math. Okay. So we have, I have a calculator somewhere. Here we go. We're going to need a calculator. So we have what is called the circumcenter theorem, okay? So the perpendicular bisectors of a triangle intersect at a point called the circumcenter. The circumcenter in this point is D. The circumcenter that is equidistant, that means it's the same distance from the vertices. So that means to each vertex, they measure the same. So that means BD measures the same as AD, measures the same as CD, because it's equidistant from the center, circumcenter, to each vertex or point. So those equal each other. Okay, so how do we use this? We are going to find BF. We're going to find BF. Sounds good. If D is the circumcenter, okay, of triangle ABC, and AC, so this whole side, is 9, okay, and DE is 1.83, and DE, sorry, is 1.83. And DF is 1.53. Got it. Okay. So in order to, these are all right triangles. Okay, right triangle. Right triangle, right triangle, right triangles. Okay, so when you have right triangles, you can use something called the Pythagorean theorem to find your missing piece. That is a squared plus b squared equals c squared. A and b are legs that form the right angle, all right? Need to know that. So A, B, okay? A, B, all right? So we know this is 1.83. What about this? AE, well, it's half of that, which would be 4.5. This is also 4.5. So we got A and B. We need to find C. Okay, we know our two legs. So 1.83 squared plus 4.5 squared equals, well, we don't know what C is in this case. C squared. So, and it doesn't tell us, but we're going to round to nearest hundredth. It doesn't tell you, we're just going to round to the nearest hundredth. Typically, it'll tell you. Okay, so 1.83 squared equals 3.35. We're just rounded to the nearest hundredth. 4.5 squared 20.25 equals, well, we don't know what c squared is. So 20.25 plus 3.35, 23.6 equals c squared. We don't want c squared, we want c. So we take the square root of both sides. And you get c is approximately, because remember we rounded, 4.86. Okay, rounded. All right, so that's c. All right. So if this c is 4.86, this c also has to be 4.86. C. This is A. We want to find B. Okay. Leg, form right angle. Let's find B. So remember, A squared plus B squared equals C squared. We know A is 1.53. We do not know what B is. We know what C squared is. Okay, C squared is 23.6. We already know that. All right. So A squared, please. Okay, so let's square A. 1.53 times 1.53 equals 2.34 plus B squared. We already know C squared is 23.6. Subtract 2.34, subtract 2.34 from both sides. B squared is 21.26. We don't want B squared, we want B. Take the square root of both sides. B equals approximately, because remember we are rounding, 4.61. Okay, so 4.61, we found our answer. All right, so you need to see some math for these. All right, other ones are some basic math. You need to see some answers, but for these, for on your assignment, I do need to see your work. Thank you.